Thank you everyone for coming to our first shop tour. I hope this will be the first of several of these because I think it's really valuable for folks to interact with other people who have setups for tools, who are running small businesses, who have garages where they're doing all sorts of hobby things, and we can learn from each other of what tools work well together, what processes work well, and hopefully inspire each other to build and do more. For the first one, I picked someone who is easy to ask, my brother, in fact, who is in Michigan and has a shop in his own garage. And so what we've asked him to do is he's going to do kind of an overview of the shop, show you what sort of tools he has, what he's picked and how he's organized things, what his goals are. And then he'll go back around and we can ask questions about the specific tools, specific processes. He could talk a little bit about the products he's invented and the process he's gone through them. So without further ado, I introduce Ben Logan from Americana Manufacturing.
Hey guys, can everyone hear me loud and clear? You guys, can you hear my audio?
Yeah, we can. You're just a bit quiet, but yeah, if you speak up, you're good.
Okay, sounds good. So I am Jared's brother. Like he said, he runs the maker space out in Connecticut, and with everything going on in the world and everyone at home, he thought it was a good idea to show my space and maybe inspire people and then exchange ideas. So here we are. We're in my barn in Lapeer, Michigan. I know he asked first to go around and kind of ask why I organize the shop the way that it is, but working in a smaller space, this is a 1,000 square foot pole barn, you're confined to, the limitations of the space. So I kind of put everything in an order that was just a good workflow for me. And I do a lot of car restoration, a lot of prototype, and a couple other things. So the garage needs to be able to shift quickly. So I guess we'll start looking at some of the tools. Right now, my dad's filming, and where he's standing is kind of what I call the car bay, because I pull the cars in here, and then I reorganize the shop to do a car restoration. Right now, I'm actually manufacturing chicken coops, because with everything that's going on, everyone went out and bought chickens. And then I guess Amazon sold out of those little chicken coops, and then Tractor Supply started selling out of coops. And I had a bunch of coops designs that I already designed when I was younger. And I kept getting emails of people wanting chicken coops. So finally I caved, and now I'm making as many chicken coops as possible a week. Right now it's about 4 chicken coops that my dad and I physically can make, but we're designing it to be a kit, and we're going to box it, and I'm going to try to get it into some local, maybe Tractor Supplies or other farm and garden stores. So let's do a little pan shot of the shop. This is Alpha 98 4x8 ShopBot CNC router. It's a little older. I want to say that it's a 2006 vintage, but it does the job. I've got it hooked up to Windows 95, so it gives you an idea of age, but it performs wonderfully. It's a simple 3-axis router. I actually have something I just cut on the table last night, so we can take a look at that. This is, so you can kind of see what it is here. That's one side of a chicken coop. It comes perfectly out of a 4x8 sheet. And then this would be the other side. And on the table, you can see that's exactly what we have here. So what we did, we V-cut grooves to give the illusion of clapboard siding. And then I did that because proportionally you can't buy bead cut board that would have that size in it. So this just gives it that illusion. Then it has little shutters. This is the back. This is the front door, for example. So you can see here, once it's cut, it looks like a little raised panel archtop front door. And that will be painted with a screen in the back. And these turn out really nice. And one thing about the design that I have here is everything is tabbed. So when it goes together, there's no mistakes, and it's very strong. So you can see all these grooves cut in here aligned to another part.
Yeah, so can you hold it closer? Just because the resolution is low, we can't see the details.
Yeah, it's just the tab here. You can see the tab design.
Oh, yeah. So
that locks into other features. Like you can see this groove here accepts like a piece. This isn't the piece that goes in here, but you get the idea. Anyways, this router is probably the most versatile piece of equipment that I have in the pole barn. It may not look like the most impressive, but I say, pound for pound, dollar for dollar, this is the best machine that I have. It's great for prototyping. I've made vacuum tooling on it. My dad's done a number of things on it. We've made molds for fiberglass tooling. And then obviously chicken coops, signs, it's great. It'll cut all kinds of different medias. It's not good for anything they need lubrication, so it can cut real thin aluminum, but you're not going to be able to do steel or anything else, and the aluminum's limited. But there's a lot of soft medias like plywood and Ren board and stuff that you can cut that's just absolutely amazing. So let's move forward. Here's some projects that I got out for this, and we'll talk about that in a minute. This is a Haas. This is a 2004 vintage, so it looks a little more impressive, but it's still an older machine. It's a mini mill. The reason I bought a mini mill is because I'm working on a barn and I needed a smaller machine. They weigh a lot. I think this one's 8,500 pounds, so it's difficult to move around. And the bigger they get, obviously, the heavier they get. And the biggest thing is it runs off single-phase power, so I don't need to run a phase converter and have the noise of the phase converter running because I don't have three-phase out here. I can convert through a phase converter, but it's still limited to how much single-phase amperage you can put in. This would have been fine. It doesn't consume a lot of amps, but for what it is, it's not a bad machine. Right now, there's a project going on. This is a side of an injection molded tool that's sitting in here. We'll go over that in a little bit too. So you can kind of see what we're doing. So what this does, this machine does harder materials. Obviously, it's a smaller footprint than the shop bot, but it's the same concept. It's an X, Y, and Z. This is just more rigid, more accurate, and has a lubrication system. So that's why we're making the injection molded tooling in this machine here, opposed to, say, a shop bot or something like that. You need the accuracy. So if you come over here, this is a 50-ton injection molding press. And this thing weighs, I think, 11,000 pounds. It actually weighs so much it cracked the floor. It's one of the reasons I need to upgrade my shop from a pole barn. And it requires so much amperage that we were running it through a phase converter, and we were starting to burn wires out and stuff. So I asked DTE to bring more power in, and they wouldn't bring me any more power because I'm already maxed out. And to bring in three-phase, I'd have to change a couple things out, and it didn't make sense. So I have to get this one into a bigger shop. But basically what this machine does is you put plastic pellets in here. It comes down here through the screw, and then the screw has heater elements just like your printer head on a 3D printer, and it extrudes through the center here. And when you have your die mold in here, it actually injects the hot plastic into the die that you make, and you can change how many ounces and how much pressure and stuff through the PLC. But at the end of the day, it opens and closes, and you get a finished part come out. So it's very accurate. You get a ton of parts out of it, and it's cheap. So it requires a lot of setup to make an injection molded tool, but once you're there, you can make parts like crazy. So I actually absolutely love injection molding. Here we got some of my car restoration stuff. This is a 78 Volkswagen Westphalia engine that needs to be completely gone through, rebuilt. And I just kind of set it aside. It's causing a lot of chaos right here because I have a lot of parts around the garage. But with everything going on, I thought that it would be more lucrative to make chicken coops right now than sell restored cars. So I have car parts all over the place from cars that I was like halfway through working on that I pushed to the side, and now I'm making chicken coops. But that's another story. So those are car parts. This is a smaller injection molding press. I can run this one in the garage. This one is three-phase as well, but I run it through this phase converter panel that you can see on the wall. I don't know, it's probably hard to see, but it's a rotary phase converter. Basically, it's another motor. You put 220 single into it in two different spots, and then it breaks the third leg off to create three-phase. Here you can actually see there's a little injection molded die in here. And this is just one that I had. I didn't make this die. But what it did is it makes a small lanyard for, I think, advertising purposes. So they probably ran it at a show or something. And then what you get out of it is this little part. So you can't really tell real well, but there's a little hole for a key lanyard. And on the actual thing, it says Boy Machines Inc. So Boy is the company that makes this. And it's a tooling company, and they're kind of bragging about what they could do. This is probably from the 70s. And what you do is you would break it off, and then they would give it to somebody, I would imagine. So what you have here, this is the configuration that you need for injection molding too. So you have your sprue. You have what you call so the sprue is the spot where the hot plastic's initially coming in, and you can see how it's tapered. This is right where it's connected to the sprue. When it comes through, they call these the runners. So this is where the plastic's running into the part. And this is a fan type gate. So this gate right here is thin, and it's supposed to be, this is polypropylene in here, so it's pretty kind of waxy and flexible plastic. But if it were something a little, more rigid, you could probably snap that off. With this, you'd probably have to use a razor blade. But after that, this is your finished part. This becomes scrap, but it's not really scrap because with like polypropylene and stuff, you can regrind it into pellets and then mix it into a certain percentage. So you can just keep reusing it and reusing it. So it's very efficient that way. And you can see how that fits right in the die right there. So when the plastic's hot, it injects into here, and then it actually sticks to that side of the die, and they have what they call an ejection pins here. And these pins come out and they hit the part off of here, and it will drop down, and then that'd be a finished part. So I don't know if you can kind of get that concept, but that's why I love these machines, is just because you can pump them out fast. So this is a cool little machine. It's older. It was not expensive, and it's fun. I mean, I don't have anything running in it right now. It only does 0.6 ounces, which isn't very much. But if you got a part that's 0.6 ounces and you need, a couple 100,000 of them, that's probably the best way to go. So yeah, that's kind of the shop tour. I don't know, you can kind of pan around and see different things. It's not that fancy. We have table saws, band saws, and stuff, but they're more out in the driveway right now. I guess I'll go over some of the ideas. Is there anything else I should cover there, JR? Or?
Yeah, well, I guess, do you have a finished coop around that you can show?
Yeah, it's a little rainy out, but we'll go out there and we'll check it out. So this is the last Home Depot run I did. This is all the wood that I need to cut today. So when we're done on the phone, this does enough to do 4 chicken coops. I can cut out the material for 4 chicken coops, and I'm going to cut all this out today. It should take like 8-9 hours on the CNC to cut most of that, and the rest will be hand cut. So this is one of the coop models. There's several models that we designed and make, but this one, I call it the Carolina coop because I actually went on a road trip with JR. We stayed with one of his friends, Jake, and they lived on, Folly Island, South Carolina, and I love the style of the houses. So they had like a lot of old salt box style houses like you'd have up in New Haven, but they had the tin roofs and stuff. So I call this the Carolina coop. It was inspired by that trip. You can see here's a little arch top door all painted and everything. It's actually a little swollen from that, but here's the shutters all work and close and open. We made a little plaque for here. And then this opens up. And if you look inside, it's a small tractor coop, they call it, because you can pull it around the yard. But all these nesting boxes, they just are all CNC'd out and they fit perfectly in place. It has a linoleum floor. I'll use the drop down ramp here. And if I pull a cord on the side, you'll see that just drops down. So it just gives it, when you have to move the tractor coop around, obviously you can't have something permanently anchored to the ground like that. So that just pulls up and down. And yeah, it's just kind of a nice little coop. They sell for about the same price your overseas models do, a couple $100 more. And they're like 5-10 times the size. And I also have people that I've sold to like 5, 6, 7 years ago emailing me now that I'm making them again, saying they wanted another one because this one lasted so long and they love it. So it seems to be a good product.
So Benny, though, I know that, so this is a problem that like other entrepreneurs have, is that, so you have a product, people love it, and you have 2 problems: how fast you can make it and how you can ship it, right? And you want to just talk about why you've gone with other products rather than focusing on this, and what your challenges in those areas have been?
Yeah, okay. So one of the things is shipping. Shipping's huge. One of the problems with this is you're shipping a lot of air. It's ginormous, so you have to freight it. I've shipped these to New Jersey, Louisiana, all over the country, and people actually paid more for shipping than the coop cost, but they just wanted the coop, so they were willing to make that sacrifice, I guess. But most consumers are not going to do that. That's why knocking this down into a kit form would be crucial, but even then it weighs 350 pounds flat packed on a pallet, and you're going to need a lift gate, and it would be an expensive transport. So you're you would have to get it into somewhere like Tractor Supply, but at that point, your manufacturing has to be through the roof, and you better be making like 20 coops a day. So it's like, how do you overcome the financial hurdle, make the connections? So I've always gone with smaller products. So this is kind of the learning curve that Jared's trying to push me towards, but I always went towards smaller products after making larger, heavier products, because the smaller one, if I can keep it at a low shipping size and weight, it's more attractive. And also with injection molding, which we'll get into a little bit more, I was able to manufacture products that were smaller, shippable, and even though I don't make a ton of money off an individual sale, I sell a lot of them. And so it creates a lot of revenue that way. One of the products that we were making for a while was stepping stones, which was silly. Here's one of them over here. This is like when I was younger. Actually, I think my dad made this one, but he made a mask for it too, so it could all be painted. It's just the compass rose, and on the back, it's stamped Logan products. But yeah, we had so many different designs, and I sell them like crazy. But like JR said, if you have something that's heavy, like obviously that's condensed, but it weighs 60 pounds. So you're shipping something that weighs 60 pounds, but it's only worth $30. So, you know, the shipping is going to be $500. You know, who knows what the shipping is, but it's expensive, and it's not a realistic product unless you're selling it locally, which you can make some money locally, but it's just not practical for scaling. So, and also I found out weighing like 160 pounds and moving around cement all day long is not my thing. It was too much work. So let's go back in the garage here. All right, was there anything else that I didn't cover there, JR?
No, I think that gives folks like a good idea of your challenges and how you adapt to them. Why don't you show us some of the other products you have on the table? And if you want to, I think it was great to talk about the injection molding. And if you want to talk just about the kind of pros and cons of why you've done different things. Yeah.
Yeah, absolutely. So with things that you can do and you can manage, that's why I love the ShopBot CNC. Not that I'm trying to advertise them for anything, but you can see that I can make chicken coops. It's versatile. I've made a number of other products. And even though it's a little labor intensive to have to cut each one and sand them, it's a great way to get started in kind of manufacturing and selling stuff. Here we'll talk about a little more complicated stuff. This, for example, is one of the products that I sell. So this is a small injection molded capsule. And when I came out with this idea, you know, I like ideas and products that will have a potentially positive impact on the environment. And I also like stuff like the critter cribs, the chicken coops, the beehives, animal housing, things for creatures. So this is one of the ones that kind of fall into what I want to do, like what my mission is on making products. It's a root pod. So this is a small plant cloning device. I was scrolling through Facebook news feeds one day, and I saw this thing on air layering, which is an ancient technique or an old technique for propagating plants. And I thought, wow, how cool would it be to have a little product like that to use on smaller, more delicate plants? I designed it, 3D printed it, and then launched it on a Kickstarter campaign, which failed. And then I made the improvements that my brother actually suggested, like work on your video a little more, improve your 3D prints, show the concept better. And then I pre-sold $8,000 in the first month, made a tool, and then started selling these. So this creates a good revenue for me every day. Right now we're currently sold out, but you know, I have to make more. Sold out yesterday. But yeah, this is a little capsule. It has a living hinge on it. So it closes, locks, and it has a little latch that clips. And this is filled with a moist peat moss. And when you put it on the plant, it goes to the mother plant. The stem goes through here. Roots will be established on the inside. And once roots are established, you can cut that stem off, and then you can open the capsule up, and that new clone will be ready to be planted. So here's what the finished product actually looks like when it's done. This is a starter kit. And if you go on rootpods.com, there's some stuff. I have some YouTube videos on how it works. But that's the packaging. All we do is injection mold the product. There's little foam inserts that actually go on the pods, so it will contour and seal against different branch diameters. We make this rooting gel out of a willow tea and honey. and then it just comes with instructions and then peat moss. So that's your general starter kit. But yeah, it's, you know, normally I sell like 10 of these a day, and then I have gardener kits and pro kits. But yeah, this is a good little product. Um, this is the mold that it's actually. This is actually not the mold that these ones are made in, because I have two molds. This is a mold that I designed on Fusion 360 and then was making on the CNC, and it's a lot to chew because I'm not the best machinist in the world. And one of my friends actually came over and he's like, dude, I would love to play on your CNC and help you make this. So we cut this tool together and it turned out amazing. So you can see here, um, Fusion 360 is a great software to draw on. It's maybe not the best for making injection molded dies, but it's certainly affordable because I got it for free. Drew all this on Fusion 360. These are just rough plans for each plate. So injection mold is a series of plates. These are quick reference blueprints that we had. So when we were cutting it, obviously we cut it off of a 3D model and used G-code to cut it, and it was all programmed offline. But these are cool to reference so you know what size holes are, what reamer to get out, and what the plate looks like. So that's a nice thing to have. You can see here how the root pod perfectly fits into this. This is called the female side of the mold because it's the cavity. The other side would be called the core because it's filling the void. It's the core part or the male side of the tool. You can see here we have our sprue, we have our runner, we have our gate. This gate is a really neat gate because it's called a submarine gate, and it's going to be a little hole that's drilled on a certain angle that goes into the part. And when the part ejects, it actually breaks that off, so you don't have to break it off each time. It will just automatically break off. These are the air vents, which are machined into it. So as the hot plastic comes in, the air will be able to escape out of the mold. And then that's one side of the mold, and the other side is this. This is all the ejection pins. So this is like a spring-loaded ejector plate that comes back and forth. So once that part is finished being molded, this is the part that ejects that we talked about earlier. And then the other plate that goes on here is the core. So as you can see, this is a pretty intense and complicated tool. It still needs the cooling lines drilled into it and the bushings. But once this is made, this will make 2 root pods a minute, if not 4. So I'd have to run it to know the cycle time, but yeah, you'd easily be able to make 2 root pods a minute on this tool, which is nice. So that's injection molded tooling. Before I learned this, I self-taught myself how to do this. So I watched a ton of videos, I read a lot of articles, and I never went to school for CAD or anything, so I had to learn all that by watching Fusion videos and stuff. So my dad initially taught me how to use TurboCAD 2D, TurboCAD 11, and then I just kept going with it. So like originally when I was a kid, I would be like, Dad, I want to make this, and he'd draw it up for me, and then eventually got tired of that and was like, no, you need to figure this out and draw this yourself. So I just kept going with it. Now I'm making injection molded tooling, which is kind of neat. And yeah, let's talk about some simpler tools.
Yeah, so Benny, somebody wrote a question into the chat, which was, have you pursued patents for your designs?
Yeah, so root pods is patent pending right now. It's pretty easy to do. You can go to the U.S. patent website. You can file a provisional patent for around $100. It's a little kind of pain in the ass to fill everything out because you don't want to be really specific on what you're patenting. You want to keep it broad. That way, when you go to a patent attorney, they can be like, oh, well, you didn't really narrow that down, because you want to leave it broad. If you narrow it down too much, you might make your patent worthless. But yeah, I would say if you have the money, go to a professional. And if you don't, you can file a provisional online, get your idea out there, show people, and the provisional will protect you for 1 year while you're kind of showing people the idea. And then after a year, it expires. So then if you don't within that year go to a professional or know how to do a patent yourself, it's going to be void. But you know, the patent thing, I don't think it's that important. It's great if you want to protect your idea to agree, but really if someone that had more money than me wanted to come in and steal this, I don't see why they couldn't, because at the end of the day, you're gonna have to protect your patent and hold them up in court. So, you know, just try to get ideas that won't be stolen and keep pushing the idea forward. But yeah, if you want to get patents, you can get patents. I've filed quite a few. Yeah.
And then somebody asked, did you ever do trade shows or other events?
No, I've gone to like small shows and just talked about stuff, but I've never done a trade show or anything. I started at farmer markets selling stuff like little bird feeders and stuff that were CNC cut. and then kind of scaling products and then scaling them back again.
Great. Those are the questions. You can keep going to your next.
Yeah, no, good questions. I love them. So I'm going to talk about some really simple tooling, and I know a lot of you guys on here are makers, so you might be interested in some of this stuff. And I made quite a bit of money off some of these past ideas. I just stopped doing them because I got tired of doing them. So basically, I'm really all over the place, and I'll do something for a while, and it'll finally start breaking through, and I'll back off a bit. One of the reasons I backed off this one is just because it was labor intensive, and it gets kind of boring doing stuff like that. But these are called coasters. These are things that I made when I was younger. And here's a cast one. I had these all different ones. So this is a Detroit set. This says music, Motown music, and it has a lady on a microphone singing in the moonlight with the Detroit skyline in the background. And this is a good seller. I don't know if you can see it or not.
Yeah, you have to hold it really still because it takes a minute for the resolution to catch up because of the connection. Yeah.
Yeah. So this is just the urethane plastic, the raw casting. Eventually what would happen with this is we would stain it, and it has a bunch of wood grain already molded into it. It would look like wood, and if even woodworkers would get this and they'd be like, oh man, this is oak, this is beautiful, and it's not. So the way we made this, we took a piece of oak, I drew a 2D drawing, I took the 2D drawing, programmed it for the ShopBot CNC router, it routed out a router path, and then what we did, we took a wire brush to raise the wood grain, and so if you felt this, it's very rough. What we did next is then we mix up a silicone rubber and we made a casting. So we'd pour a liquid silicone in here. That silicone will cure in the mold. And then when you demold this, you have the mold, you have the image that you need. And what I do then is mix up a 2-stage urethane plastic, and then you just pour it in here, and with 3 minutes it's cured and you can demold it. And I do that until I had enough to make a coaster set, which was 4. I actually have an old mold. I don't know when this was poured. It must have just been put in the back after it was done. So you can see this is a coaster holder. This has been poured already. And I'm going to go ahead and demold this for you. I'll try to do it slowly. This has been sitting for years too, which is kind of comical, but it's not like it goes bad. Basically, all I do is just break loose the edges, and then the silicone's very flexible. The urethane's hard. You just pull that out, and if you look at this, kind of neat. You have a nice finished plastic part without having to create a complicated injection mold. Has tons of detail. Obviously, it costs more than injection molding, but the coaster sets, I was selling them for about $25, and I don't remember what my actual material costs were, but it wasn't much. So this would be, like I said, it would be finished, and then there would be felt glued to the bottom. And what would happen is you would get 4 coasters together. You put the coasters in. The coasters sit in there perfectly, so it's a nice little set. Or if you rotate it around and you don't want the Michigan thing, I designed it so the image on here contoured the writing, so you'd have a nice picture on your side table or whatnot. So yeah, I did that for a while, and then kind of moved on to other things. But it's a cool way to get started. Jer actually came home one Christmas and made a bunch. He made this mold here. This is our Logan tartan. And when I cast the last thing I made for the chicken coops, I went ahead and made my own mold because he took the mold with him, and I always wanted one. And then this is one he made for a friend, C-Clicks Fix. I don't know if he made this for making coasters or they were casting chocolate in it or just for fun, but Jer made a bunch of them, which was cool. So he saw what I was doing, and he's like, I want to do it too. And hopefully you guys will want to do the same thing. So yeah, there's a bunch of different, these are all different molds for coasters right here. But it just shows you how versatile that CNC is if you just kind of use your imagination. And this didn't cost a lot to do, and it generated quite a bit of income. Kind of a neat little project. So this is the same concept we were able to apply to this. I actually made this one last week. So this is a new project. This was for the chicken coops. When I got back into making the chicken coops, I wanted to look a little more profesh, and decided to make a little name plaque for it. So it says Critter Cribs, designed by Ben Logan, made in USA, Lapeer, Michigan. And it has a little picture of a chicken. So it only took a few minutes to draw up. It's basically a circle, a square, some fillets, and then I offset the square to create this border. Did the same with the circle, and then I went online and looked for a JPEG of a chicken profile, and downloaded a free software called Inkscape, did trace bitmap to path, created a vector image, and off the vector image, I was able to just throw that vector chicken into the circle. And then for programming, it's super easy too, because it's 2D, it's a 2D drawing. So all I had to do is specify the Z height on the CNC, and then I just put it at, I think, 100 thou, and then cut 100 thousandths of an inch in with a 1/8 inch cutter, and was able to get all this detail. I countersunk it, so when I cast it, I would be able to create this mold. So by countersinking it, all I did was I didn't have to build a box up around it. You can see this is the mold. You saw the plaque on the chicken coop, which was painted to look like copper. And it works the same way as the coasters. You just mix up a resin, you pour it in there, you get a beautiful mold. And when people see it, they'll be blown away because they're going to think I have a cast bronze or, you know, a nice machined copper plaque on there. And it's really something that I'm able to replicate quite easily and maintain a nice professional level on my products by doing, you know, prototype style stuff like this. So any questions on casting urethane or making silicone tools?
So no, the only question was, so how many profit centers or products does he have? And the answer is a lot. They're not all active.
A lot. So not all products generate money. A lot of them are just ideas, and a lot of ideas that I chase, there's a reason I stopped chasing them, or a lot of the time it's just I can't overcome the financial hurdle of what I want to make. I'll show you some of those later too. Right now I'm going to go over a little vacuum forming tooling, which is another great way to make a product without getting something as intense as injection molding, blow molding, or, you know, something where you need a lot of capital heavy tooling to do. This is something you can do in your oven at home, and you can buy polystyrene or ABS sheet. It's super easy. We're going to go over it right now. So this was a concept idea that this is kind of a side product for that other idea. The first idea was called a Perch Potty, and it's actually a chicken toilet, which sounds totally ridiculous, but it's a vacuum formed tub that holds perches, and it has a water spout on top. And when the chickens go roost at night, when they take a chicken dookie or they poop, it goes into the Perch Potty instead of on the floor, so you don't have to clean the floor anymore. And at once a day, it automatically washes the chicken droppings out into a bucket. And so this was, I needed a lid for the bucket, and this is how I created this lid. So if you look at this, I'll show you. Here's a 5-gallon bucket. This would actually be drilled out, and there would be a pipe that comes into here. And the design kind of looks like a hat, but I'll show you why it does. It perfectly fits onto a 5-gallon bucket. And then this feature right here, I incorporated it. I measured the distance from here, and it snaps on. So now you have a perfectly sealed bucket, and it's locked on. You can still carry it around with the lid on. So I created this product super cheap. Like I said, I didn't make any money off of it because it's a concept, but I'm going over vacuum forming with you guys just to show you one of the things I did, and this was a quick thing I was able to grab. Here's the tooling for that. So the tooling for this vacuum form piece is right here. I didn't make this out of aluminum. It's nothing complicated. I went to Home Depot. I bought 1/2-inch MDF, which is just like a medium density board, I think it stands for. It's kind of like a cardboard type consistency, but even more dense. When I designed it to just in a 2D drawing. So I imagined the 3D part I wanted to make. I'd made 2D circles. So it's a 2D circle, a square plate. And then you can kind of see the lines here. I took the profile that I wanted and then cut a series of plates, glued them all together. Then I used polyester resin, also known as Bondo, mixed it up, covered the piece, and then just used a sanding block and sanded it to get the final shape that I wanted. When I designed it with a hole in the bottom. And what you do is you create it hollow on the inside, and you drill a series of holes into it on all your low points. And what happens is you heat up a sheet of plastic. Like I said, this is very easy to do too. You just heat up a sheet of plastic. It probably needs to be in a frame, so you create a wood frame if you want. Heat up a sheet of plastic. You hook this up to vacuum, so you're removing atmospheric pressure, and depending on altitude, you can generate, what they call it on mercury, so they use a mercury gauge. They might use a different gauge now, but originally we had a mercury gauge. It's usually 15 pounds per square inch, depending on altitude. So at sea level. What is it, 15 pounds per square inch in altitude? Yeah, so at sea level. Anyways, what it does is it puts a lot of pressure on that molten plastic, and it sucks it down to whatever shape you have. And as long as you don't have any undercuts that locks the piece on, you can see that this is all drafted to come off. So this will pop right off, and then you just trim off the rest of the plastic, and you have your finished part. So that's another cool way that you can create something that will really impress people easily. And it's a nice plastic part. There's lots of vacuum form parts that I can think of that you probably use that all the time. One that I'm thinking of right now is like a toboggan or a sled. Like the little saucers and stuff. That's all vacuum molded stuff. Usually your fast food containers, those are on a linear vacuum forming thing. Like you go to Taco Bell, you get the nachos. It's all like vacuum form stuff. So it's used in manufacturing all the time, but it's a great way to prototype an idea as well. Any questions on vacuum forming?
No, I don't think so.
Okay. And then obviously you guys being makers, you know all about 3D printing. So here's a prototype that uses a combination of a lot of things. This top was vacuum formed, so this was made the same way that was. We made a plug like this, a wooden plug. Vacuum formed this piece. You can see that it's just that's actually really dirty because I used this for bees for a long time. But we sprayed it copper anyways, and this is a lid. It's a decorative lid for a beehive that I designed. And it turned out really nice. We made quite a few of these. Here is the prototype beehive that I worked on for a number of years. Again, we vacuum formed the skin right here, so we got all this detail. Then we built a mold where we had a distance. We filled that mold with a closed cell urethane foam. So what we were able to achieve, instead of having a beehive that had a strictly wooden panel, we were able to create an insulated panel that's already pre-colored, so you never have to paint it. It never rots. And it has an R value, which is the value where heat, hot and cold can transfer through an object, about 8 to 6, depending on how much foam we put on, how it's laminated. And a beehive at 3/4 of an inch or an inch would have roughly 1 as an R value. So the bees have thermal stress from being in the beehive, and with this one, we reduce the thermal stress. I actually put a provisional patent on the venting system on this hive. So this venting system opens and closes automatically with the temperature changes, which regulates the internal temperature of the beehive, allowing the brood or the offspring to actually be healthier during transportation or on hot days, less die off, and you have the next generation be healthier, stronger, and you also have healthier bees out of it. And yes, I did test the idea, but this is one of those ideas that I spent a long time with money and research to develop. And then when I got to the point where I actually want to sell it, you have a financial hurdle that you can't get over. So I took this to an injection molder and asked how much to make, and they said $500,000. That's when I decided that I wanted to learn more about injection molding, and that's when I came up with the root pods idea, so I could discover how to make injection molds on a smaller scale. And then I bought this machine because to make the root pod mold, they wanted $23,000, and I bought this machine for $17,000. So I figure if I made one mold in this machine, it pays for the first root pod mold, and I can make other molds in this. So that was kind of like the progression of why I went that direction. But yeah, it turned out great with my, help from a friend. We made badass mold. We have root pods selling like hotcakes, and I know how to make an injection mold now. So I've overcome that hurdle, and I brought the price down from $500,000 to make my beehive down to more like $80,000. So the next thing is make beehives basically, but I still need to kind of get there. But yeah, that's it. I guess the limitations are my machine. I bought a machine and I don't want to make parts that are too big for the machine, but I got to sell this, upgrade, get a bigger machine, and then I'm gonna make beehives. So it's basically it'd be nice to pay the $500,000 and have this made, but at the end of the day, if I don't have the money, I'm gonna find a way to do it. And that was just one way I did it. But back to the prototype anyways, these are all 3D printed parts to get the concept. I was able to 3D print these parts, vacuum form these parts, create a prototype that represented a production model, and I was able to put it in the field and test it with bees and then make design alterations until I actually had a better product. It was no longer a concept, it was a prototype product. Now I just need to make this product on a production level so I can sell it and be competitive in the market. And I applied all the things that I learned in the past by having this knockdown flat, making it shippable, making it light, making it cost competitive. So it's basically all the things I learned on failing to create a product that, fits in all the categories that I need, essentially.
Great. Is that cover it? Do you want me to get some, see if other people have some questions they want to ask by voice?
Yeah, let's do some questions.
Yeah. So, from y'all, what do you want to know? Feel free to type it in the chat or unmute and ask your question. So doesn't seem like we have any questions.
Did everyone leave? I'm like super lame.
No. I thought it was great. We have we have like 6, 7 people. Jared's gonna ask a question. It looks like. Go ahead, Jared. Oh, I'm not hearing him. But Julie asks, how much did it cost for you to make the root pod molds yourself?
So when I was quoted, it was quoted at $23,000, and that was with me doing the design work. So I already had the design pre-made. I sent the plates out to different people, and the best quote I got was $23,000. I was able to buy all the materials for $1,600, and then my friend helped me for free because he wanted to learn. And then with the time that he spent with me, I feel like I could handle this machine now. So not that I'd want to spend the time and make all the dies myself, because it's a big project, and it does require a pretty good machinist to pull it off. But I think it can be done. But yeah, $1,600.
So Jared said, not sure why his unmute wasn't working, but he saw that the root pods were not on Amazon. Did you part ways with Amazon?
No, root pods, I put the inventory at 0 on Amazon yesterday, because with everything that's going on with the COVID, I had to take root pods off the market. The molder in the back is big enough to mold the root pods, but like I said, we had some power issues running through the phase converter, drawing too many amps, and then blowing breakers and stuff. So I ended up having the root pods molded at a manufacturer, and which made it obviously more expensive per root pod because you're having someone else make it, but it worked out. And that manufacturer is now down because of COVID, so they're not working anymore. And for some reason, with everyone home, I sold all my root pods off in a few weeks, and now I have no root pods left, no way to make them unless I can hook this thing up to power. So I had to pull root pods off Amazon for a short time until I can get my supply chain sorted out.
Yeah. And somebody asked, what's your most profitable product? What's covering your costs and expenses?
It's probably a combination of everything, because the root pods and stuff is seasonal. So you're going to make the most amount of your money in the springtime, and then other products might be a wintertime. Honestly, it sounds crazy, but my most profitable thing is doing car restoration. I restore mainly Volkswagen Westphalia campers. I have one out here right now. I bought it for, say, $2,000, and I'll sell it for $35,000, and it'll take me about 2 months to restore. And I'll probably have about 8,000 into it. So it's all labor costs, and I don't hire anyone to do it. I just do it myself. So I normally buy a car, restore it, I'll sell it, and then I'll buy some giant piece of equipment to chase some idea, spend all my money on that idea, and then restore another car. So it's kind of one of those cycles, but I'm slowly accumulating a shop here. So I guess it's kind of working.
And I guess this is my own question is, so your goal, though, is to get away from doing these one-off labor-intensive jobs and create a product that can be mass produced and create stability, right? So like that's the cars isn't a passion, it's a stopgap measure while you get these other things lined up.
Yeah, the cars are a great way to use my own skills and a small amount of money to generate a larger amount of money that I wouldn't be able to make at a job to finance my projects. So that's kind of the way. I'm getting to the point now where my products are replacing any job that I would need, though, and they're consistently selling. But the cars are always a great way to come up with money quickly. So that's why I bought the Haas and stuff. You just restore a car, sell it, buy a machine, then spend months making a mold. You run out of money, buy another car, do it again. So I gotta take my burn rate down a notch, I think. That way I can just make products all the time. But Yeah.
Somebody asked why you're not using a portable power generator to power the machine.
Yeah, you could. I could go out and buy like a giant generator. For the 100 amps that I need, the three phase, I think you need a 25 kV generator, which is a very large one. So you're talking like a diesel generator with a semi truck motor and a giant, motor on the back of it. So that runs probably $8,000 if you can even find a good one that's used. Those are so expensive, it's crazy. But I found used ones for around 5 to 8. But then you're still burning diesel fuel, so now the cost per part's going up. The maintenance on the rotary phase, or for the phase converter or the generator, I mean. My best option is to get a commercial spot, which I'm actually on a waiting list to get one locally, but it's going to be another 6 months, so I'm kind of just waiting on that. But yeah, commercial space, I'd be better off spending $8,000, get the commercial space. They'll pay for a year's worth of rent on this particular thing. It's 2,000 square foot, three-phase power. Not huge, but rent's cheap, and I want to get in there. So we're going to move my equipment in there and be able to power it up. So I guess I'm just paying for storage right now in this thing here. But yeah.
And would you choose to manufacture, when you choose to manufacture on a larger scale, would you do it in the US or abroad?
So yeah, my company's name is Americana Manufacturing, and I've traveled abroad, and I've been to, all through Asia and stuff, actually programming robots. And I got to see firsthand that I didn't like the way that labor was exploited. So there's someone on top making tons of money, and then there's people on the bottom. And in their society, they're quite scared of the people on top. So they'll work ungodly hours in terrible conditions. And I didn't like the concept of just, it's kind of like the American way now, too, where they just want to send something overseas. They don't care where it's made, turn a blind eye, sell it here. And as long as they make a profit, who cares? I don't like that philosophy. I'd rather make it here. I'd rather pay a good wage, maybe even profit sharing or something good to give people an incentive. Be like, hey, we're a team effort. We're making something great. I'm able to control the quality of the product. I can make a better product. And I like the manufacturing process in general. I like being involved, and I don't want to outsource something and just be, hustling a product. It's not my style. So yeah, 100% I make it here. I like to be involved in the manufacturing process and the innovation and design changes. I like it. It's why I got into it, because I like doing it.
Yeah. One of the folks said that they'd think it'd be great to mathematically model your endeavors and track them. So just, do some business analytics. We got another person just saying amazing, thank you. So just kind of a shout out. So yeah, so I think this is our last chance for questions. We seem to be at a good spot. Ben, if you have any last pieces of wisdom or inspiration for us, now's the time. Otherwise, we'll wrap it up.
No, I tried to cover things. I didn't really know what direction to go, because like around here, there's a million directions. I could keep pulling products off the shelf and showing you, but I feel like what I did shows the wide range of different things you can do in 1,000 square foot or smaller shop. And I just want to inspire people to use your creativity and keep making stuff. Like, if you enjoy doing it, make stuff, try to sell it, and you'll learn as you go, and you're going to fail and it's going to suck, but keep going. And, maybe I haven't reached where I want to go, but I think a lot of people admire how far I've come. And I would want you to do the same thing and get way further than me. So keep going.
Awesome. Well, thank you for taking the time to show us this. And I hope you do more videos and other things about the individual processes, because this is, it creates a lot of curiosity. There's a lot of knowledge that you get from working and learning from all these things, and always happy to hear about them and learn more.
Yeah, 100%. And always, go to MakeHaven, check it out, use their equipment, network with people. I never had a maker space. I was lucky with my dad to show me the ropes, but keep at it, keep learning. We have YouTube, and thanks guys. Thanks for tuning in, I guess.
All right. Well, and thank you everyone for joining. We'll be keep an eye. We'll be posting more shop tours. If you know any other folks that have a shop that might want to give a tour, connect them to us, and we will try and make it happen. Thanks, everyone.
Cheers.